Hey guys, today I want to talk about this distributed private cloud infrastructure that I have been testing and architecting and working with for the last few weeks. This is based on Red Hat OpenStack 16.1, which introduces some new features of being able to, for example, put the highly available storage at the edge. Before I start discussing this, I just want to make this disclaimer that I'm not really authorized to speak on behalf of Red Hat. I'm not sponsored by Red Hat or representing Red Hat and its views. These views and opinions expressed in these videos are on my own. So let me start with the kind of describing the benefits of this architecture. And I think the most important is the simplified management and a life cycle. Think of it as a single pane of glass. And what I mean by that is the system that we have in place allows you to deploy all of these individual pieces, all of these data centers or edge sites from the single place. The undercloud in this case is our installer and a lifecycle tool that first deploys this availability zone 1 between a centralized control plane and a centralized storage/compute, so hyperconverged infrastructure. And then in the next step, it deploys this distributed compute node or cluster of nodes in one of my side. And then maybe I have a single node at the edge that is also being deployed and managed in its life cycle ultimately by undercloud and the control plane here. And with this multi-stack architecture, one of the benefits is we can also, for example, upgrade each of these stacks individually and without affecting each other. The benefit number 2 is efficiency of distributed compute storage with no control overhead. So if you look at this picture, and we're gonna demo how this looks in practice, but in this picture, my central side is the only one that have a control plane. And so it does the compute storage, so the users can definitely spawn workloads and apps in here. However, if you look at the DCN1, which might be another rack in the same data center, or maybe entirely different data center, as long as there's 100 millisecond latency, less than 100 millisecond latency between the DCN1 and a central location. But as you can see, there is no dedicated control plane here. But what makes this perform well is everything is localized and highly available from that cluster perspective. So there's a Ceph component to it that is entirely isolated from the central location, and it works as a backend storage for images and for your persistent volumes, as well as it can act as an ephemeral backend if we decide to do so. And then also this brings us to this last location, which I call edge compute. Also no control plane. So if we are limited to a single server that we want to put as close to our customers as possible, it's certainly possible, and yet again we are avoiding the overhead of running the control plane and maybe slicing this machine even more. Please note, because we only use one node here, we wouldn't be able to deploy something like Ceph, which require multiple nodes to achieve its resiliency. But in this case, we're still not really pushing too much traffic across this leaf spine architecture to our control plane, since all the images and all the storage are just localized on a local disk. And then, so the last benefit, and I think that's overall benefit of that we kind of had for a while, is high availability and performance, not just in a central location, but at the edge as well. And there's a couple examples here. Let's say the edge compute, that this DCN2 location is causing all type of havoc, maybe by noisy neighbor or some network storm that is being created. Because of this architecture that we've developed, each of these zones is its own failure domain from the networking perspective. So, and storage as well. So any problems encountered at this site would not affect our availability zone 2 or availability zone 1. And we still get another level of high availability of having this control plane in a central location, being ultimately highly available with multiple control. And if any of these controllers fail, the access to the APIs is still going to be intact. Okay, so let's hop into my deployed demo environment. So this is under cloud. I just want to make sure I'm authenticate with the StackRC first, and then, as I mentioned earlier, each individual availability zone or DCN location is deployed with a separate stack. So if I type OpenStack stack list, we should be able to see that there indeed are 3 stacks. Central, DCN1, which contains some hyperconverged nodes, and DCN2, which, just like the slide before, shows it's a single local storage node. So if you're familiar with how deployment is being done, you typically create a deploy files. And in my case, I indeed have the 3 deployment files, one for central, one for DCN1, one for DCN2. All right, and if we look at the OpenStack subnet list, and maybe let's sort it by name, you will see that the leaf spine network architecture is predefined from the undercloud perspective. So there's still network isolation. The chart I was showing before was a little bit simplified. Indeed, there's more than one network connecting each of these sides, and each of the networks is being defined here as well. Okay, so how does the bare metal, how does the ironic nodes look like? So you can see here, there's really 3 groups. If you look at it, there's really 3 groups of nodes. The bottom 6 are a mix of the centralized control plane and a centralized hyperconverged nodes. These 3 right above are the 3 hyperconverged nodes running at the edge. And as I mentioned before, there's a ephemeral storage-based, a single compute running at yet another location. But as you can see, this is that single pane of glass, the management from one place, to be able to see all of this. And then looking OpenStack server list, which is the OpenStack Nova representation of this architecture. Again, we see at the bottom 3 controllers and computes in a central location, and then 3 at the leaf 1 or DCN1 location, and a single node at the leaf 2. All right, so I also mentioned there's a storage, isolated storage in each of these locations, one in control plane and one in the DCN1. So just to show you that this is indeed the case, I'm going to SSH to one of those controllers, and then just execute the sep-s within a container for my cluster central. So there's a there's that indication. And then, so here it is, 3 OSDs in my case. They're located in a control plane. If I type ceph OSD tree, we should be able to see that each of those central computes are also as storage node, right? So it's a hyperconverged in a central location of the compute. But then if I need to switch back to my DCN1, so I'm going to SSH to the DCN1, one of the hyperconverged compute, and execute the same command, ceph-s, you can see that there's another cluster DCN1 defined and isolated in its own location. And if I change ceph-s to OSD tree, you will see that indeed it's no longer under central compute host, but it's indeed all of those OSDs are located on a leaf one nodes. Just to show you the current utilization, there's 3 standard pools created, and as you can see, we are already consuming the storage at that edge. All right, so this was a undercloud view. Now let's look at it from the overcloud, which will show us how we're consuming this infrastructure as a user. So first off, let's look at those availability zones that we have defined. And we should be able to see that there's indeed multiple availability zones. Some of those are internal for the control plane. The Nova is our standard availability zone, like a default availability zone for the central location. And then, but we also see there's 3 computes marked with the DCN1 and 1 compute marked with the DCN2. Okay, how about storage? OpenStack volume service list. So volumes, again, confirm just what we've been showing before. There's indeed multiple Cinder volume services running. There's this centralized, VIP-based, if you will, Cinder volume that's pointing back to the central location, and the Cinder volume at the edge is in 3 ways: active, active, active in our case. And from the image perspective, if we look at the stores, we should be able to see also with 2 stores being defined. So there's a central store for images, and there's the DCN store. And each of the image I'm uploading would show up initially based on the store that I'm uploading it to, but I can migrate them and sync them up as I need to. So OpenStack image list, we should only have one image in this tiny environment. But if I drill down to it and see the properties, you will see that I did indeed uploaded this image to the central location and then synced it into the local store for the DCN1. So DCN1 is here and central is right here. So the image is located in both sides, and once the instance is being deployed, we don't need to push any large files over this leaf spine network. It's all going to be on a local site. And finally, the networking. I have pre-created some networks just to illustrate what's possible. I think the most noted, most of our customers in this case would use a provider network. So there's a availability zone concept, not just for the compute, but also networking. And we're ensuring that each of these provider networks are assigned to the site. So we are tagging it with the availability zone. Just for the, let's just see how this is going to look like from the network show perspective and see if we can identify that availability zone there. Yeah, there it is. The availability zone and availability zone hints are showing up here. All right, so let's finally create, let's see what instances have been deployed. So this is a little bit modified OpenStack server list to show us the most important information we want to see. And I have been testing this, so you can see there's a multiple instances deployed on a central location, which is the one with the floating IP. The other one is straight up on the provider network. There's one instance deployed on the provider network in ephemeral storage, backed by Ceph in my case, and then one instance in DCN1 with the Cinder volume attached to it. And then, this is the DCN2, a single edge node, that hypervisor that this ZeroSleep2 VM is sitting on. All right, let's create a new one. Let's create a new server and just walk you through how this works. So the only difference you will see between how would you deploy instance on a central, on a like standard monolithic deployment versus this is this one parameter called availability zone. And this parameter is available to a bunch of API tooling that you would normally use to consume your OpenStack. In my case, since I'm deploying on DCN1, I'm going to specify provider network leaf 1. And then flavor, I only have one flavor in my case. There's really nothing special there. I don't have to attach flavor to a availability zone since I'm creating this availability zone parameter here. And then image, I only have one image and my key. So everything else looks exactly the same. So now if you want to make sure that this indeed spawned in my leaf 1 location rather than my central location, I can execute the OpenStack server show. We're going to grep for the hypervisor. And indeed, it picked the compute on the leaf 1. It's the first compute on a leaf 1 in a DCN 1. Let's see if the instance is already up and if it has an IP address assigned to it. There it is. So now we're gonna just SSH to it and make sure there's connectivity between this VM and VMs in the other sites. All right, this is the first time I'm accessing it. IPA should show us that we are running on the 1061.21. It matches this. Let me see if I can ping something on the leaf 0. Or actually just to see if the routing works. I'm gonna trace route it. And yeah, we got reply right away. You can see it went to my default router. And then this is my transit network that kind of replicates the spine portion of my spine leaf architecture, and it finally got there. Okay, how about something on leaf 2? Let's see how different it's going to look like. So trace route. Yep, it's a little bit different route. My transit network in this case went to the third leaf. And then ping that other VM on another, in my case in the edge site. All right, so I think that concludes this demo. We were able to show how the OpenStack distributed private cloud infrastructure is being deployed with multiple stacks, as well how it's being consumed. Thanks for watching.